All right, good stuff.
I got it.
I know that's the last one that I made, so I don't know if I shared it with you, but I realized that like right now. So I know I keep going to do it, and then I can start with other things. Winky. Too late.
We're already rolling. Just gonna edit it.
You should might as well go from here.
What do you mean?
Maybe you could.
Please don't make something better than chapter
Got three
4.
more. Yeah. 34 out of 40. You got 6 points off of that. They were 16, 18, and 19.
So then when we upload, we just redo those ones?
No, no, do all of them. You have to do all of them.
16, okay.
Yeah, so it's the whole.
This is yours.
Yes.
Take my test.
I would though.
I think
Who else do I need to test from? Not you. All right. Gas laws.
good.
Now, to explain what I've given to you is your normal achieving the objectives slideshow, and then my favorite little cartoon strip that I use with my students. So as we start going through the 3 basic gas laws, these are illustrations to help you figure out what stays constant, what change, and what 2 factors change. So you'll put the law and then the formula next to it, so that way you can use it as kind of like a guide. Okay? All right, here we go.
Wait, I have a quick question before we start. So what's the difference between college chem and then intro chem? It's basically the same thing, right?
There's more in this class than the intro.
And if you're transferring, like this one transfers over as general chem anyway, and then the intro one doesn't.
This is for science
So
majors,
do
the
you
other
think
one
we're
is not.
time and not telling me this? Like, for real?
Are you a science major?
Yes.
Then you take this one.
Yeah, but still
I took
you
the other one already, but then I know, but then I realized for bio I actually need this class. I'm like, really? Why did you guys tell me this? I'm like, well, you were a nurse. Yeah, but still. Like, if you saw that was more beneficial, I would have taken that like a while ago.
All right, so here we go.
I hate being pretty.
All right. So, properties of gases. In case you don't remember when we talk about the states of matter, gases expand to completely fill their container. They take the shape of their container. They have a low density, much less than the solid or the liquid state. Gases are compressible, and mixtures of gases are always homogeneous fluids. Okay? The kinetic molecular theory, I like to summarize it as you add heat, you're adding energy to the particles. The particles begin to move faster because they're getting energized. The faster the particles move, the further they're going to spread apart. Okay? So that sums up what happens for the kinetic molecular theory. It's the idea that particles of the gas, even solids and liquids, particles are always moving. Solids are just vibrating in one spot. Okay? Liquids move around, they flow. Gases kind of bounce all around us because they're very energetic. They have a lot of energy. So when the moving gas particles hit another gas particle or the container, they don't stick. They don't just stay put. They bounce off of it. There's elastic collisions. So if you're physics oriented, this is where the physics comes in. Okay. So there's a lot of empty space between the gas particles compared to the size of the particles. Think about when you fill up a balloon. Okay? When you start adding the gas, when you start breathing the air into the balloon, what does the balloon do? It expands. That doesn't mean that there's a gas particle in every single part of that balloon. It just means that the balloon is staying inflated because of the force exerted by the gas particles that are bouncing around inside the balloon. Okay. Which leads us to gas pressure. Pressure is the force exerted per unit area by the gas molecules as they strike the surfaces around them. Just as when a ball exerts a force as when it bounces against a wall, or when the gaseous atom or molecule exerts a force and it collides with the surface. The formula for pressure is force per area. Write this over here. Force per area. know about Newton's laws and equal and opposite force. Something is always applying pressure to move, or if it's not enough force, then it doesn't move. In the case of the gas particles, same thing. Think about what happens if you were to take a balloon and you were to heat it. You put a Bunsen burner underneath the balloon. What are you doing to those particles?
You're making them move faster.
You're making them move faster. So what's going to happen to the energy of the collisions of the gas particles in the balloon? They're going to become greater. So what is it going to do towards the sides of the container then when it hits the container? It's going to expand. It's going to push harder out, and then the balloon at some point, the skin of the balloon isn't going to be able to contain the energy of those gas particles, and what happens to the balloon? Pops.
So they're hot air balloons?
Yeah.
Hot air balloons, it's gas laws. Yes, we'll talk about that. The hot air balloon is because you're changing the temperature of the balloon, and warm air rises, cold air sinks.
Okay.
Because of the density of the gas particles. Think about, and we're not there yet, but I'll go there. So if you think about cold air versus warm air, which one has more actively moving particles? Warm air. Cold air is moving at slower temperatures. Warm air is moving. So the warm air is going to go up. It's less dense. The cold air is more dense. It's down below. So warm air rises, cold air sinks. And when you change the temperature, you're also going to change other factors such as the pressure and the volume. So in a hot air balloon, I believe, when I get this, I believe it's the volume stays constant, the pressure changes. Because you're changing the pressure as you go up. So as you change the temperature, you're going to change, and then the balloon rises, and then the balloon sinks. One day we were out in Lancaster, and we actually were very concerned because we saw hot air balloons out in the sky, and it's not uncommon. I mean, it's very pretty, but we saw the balloon up where like airplanes go. Like it looked like a little speck in the sky moving. We're like, it's supposed to be up that high, but because of the pressure system, they had to go above it to get to smooth sailing, and then we saw them like an hour later start to descend and come back down, and we were like, oh, thank God, like they were really up there. So that's why you'll never catch them in a hot air balloon. I love physics, I love chemistry. It doesn't mean I want to subject my life to that. Same reason why I hate flying. So therefore, pressure is the result of molecular collision. It's the result of the constant movement and the collision with the surfaces around them. The pressure of a gas depends on several factors: the number of gas particles in a given volume, the volume of the container, and the average speed of the gas particles. Right, I'm looking for this. What's that? I took my new marker out. So the total pressure exerted by a gas depends on several factors, including the concentration of gas molecules in the sample. The higher the concentration, the greater the pressure. Right? Again, think about a balloon. As you are adding the air to the balloon, what are you doing to the volume of the container? Increasing it. There's going to reach a point where the inside of the balloon is going to have such a high concentration of gas particles that it can't go anymore. Okay, so it's going to have a greater pressure, and then what happens when it becomes too great? Pop. It bursts. Okay?
The same thing with the bottle cap thing. Maybe you twist the bottle and then too much pressure goes back.
Yes. Diet Coke and Mentos. That's exactly how that works. So, as the volume increases, the concentration of gas molecules decrease. So the number of molecules doesn't change, but since the volume increases, the concentration goes down. All right, so let's use the bottomless soda trick. Well, not trick, but maybe you did it. I've always done it. You shake up the bottle of soda, you put it next to your friend. Hey, can I have a glass of Diet Coke? And then they open it up, and what happens? It explodes all over them, right? Because of the pressure. But if you take a large container and you don't have as much liquid in it, it's not going to have the same force. Okay? So, or exert the same pressure, because you're increasing the volume in which that pressure has to build. When my students did a science experiment of the Diet Coke and Mentos, a lot of students realized that they wanted a bigger blast. They had to use a smaller size bottle. The bigger bottles just were giving a very little burst, and the smaller bottles were giving a larger burst. Okay?
The volume it's more.
It was more concentrated. A lot of them also open their bottles of bigger soda and drank it, so we're not gonna go into that. That also affected the results. They were thirsty on the bus ride. All right. So the pressure exerted by a gas is dependent on the number of gas particles in a given volume. Take a look at the picture. Tell me what you think. Does this make sense to you without me reading all of that? More particles in the same given area. It's kind of like if they shoved all of us into a subway. And we all had to fit in one subway car versus 5 subway cars. It's going to be a high pressure situation because we're all going to be close together in an area of a given volume.
Have you seen the subways in New York and Japan? How they actually like have people like shoved in there? Like,
Yeah. No, I haven't, but yeah, that's not something that's
no, they
clever.
were so
I don't like New York
compact
at
and
rush
stuff,
hour.
people can't even like fit in there. Yeah, like the security.
Well, isn't India, don't they sleep? Isn't there like you're supposed to lay down or something? The train, yeah, the trains. All right. So what units do we use to describe pressure? The atmospheres, millimeters of mercury, torr, and the bar. For your lab, when we do the molar mass of a gas, we should be using millimeters of mercury or the atmosphere. The conversion factor is that for every 1 atmospheres, it's 760 millimeters of mercury, which is also equal to 760 torr. This is a very important conversion. And by the way, the 760 millimeters of mercury literally comes from the tool that they use to measure the changes in pressure by putting a dish of mercury and an open-ended tube, the barometer, I believe it is. There's also a manometer, so I'm trying to make sure. The manometer is an open-ended. The manometer looks like this. Okay, and then you have your mercury, and then if there's a pressure change, the mercury shifts. The change in the height is the change in the pressure, which is your millimeters of mercury. So it's literally measuring the millimeters of change of mercury. That's where it comes from. If you look anything up on a weather app or weather.com to find out what the barometric pressure is in our area, because we're in America, they have it as inches of mercury. Kind of loses that whole ring to it, doesn't it? Inches of mercury, I like millimeters of mercury, that just makes sense. A barometer is, there's a dish, and then, I'm trying to remember what it looks like. I thought she had a picture of it. And it basically is just a closed-ended tube. And then as the pressure increases on the surface of the dish, the level rises in the tube. So that's the height of the mercury. So pressure, the atmospheric pressure inside the tube goes up.